Hello everyone, I'm Jan, a member of Impossible Cloud Network, and today we're speaking with Chris. He's playing a core role in the protocol design of ICN. We're taking a close look at the way our protocol works and all the different parties involved. Also, we're getting a grasp of the huge vision ICN has and the giants we're up against. So without further ado, here's Chris. Let's go.
So, Chris, why don't we start with a small personal introduction to you? You're currently leading the protocol design. Maybe you can go into a little bit more details about you, your background, and what you do at ICN.
Yeah, sure. Thanks, Jan. So, I'm Chris, leading some of the protocol development side in ICN. I have a lot of background in protocol development, so I've been in crypto for around 7-8 years. Started on some layer 1 blockchains, worked deeply with privacy tech, interoperability tech, and then moved quickly on to decentralized identity. I think a lot of the work that I do stems around trustless systems, privacy, and kind of returning the user agency back to the users. I've worked in fintech schemes too, fintech firms, and I have a background in physics. So I think a lot of the systems design that I do comes and stems from the systems knowledge that I learned from my physics days.
Interesting, very interesting, Chris. Great to have you on the team, and maybe we can go into the architecture of the protocol. You've prepared some visuals that you can share with the community, and maybe we can dive right in. What is ICN made of? And
sure, let's do it. So as I mentioned before, I think ICN's vision is to decentralize the cloud. We want to have a more credible and more equitable infrastructure on which the internet runs. And our job is to make sure that we have a system that does away with a lot of the centralized operation and trust that you see in the current major players. And I think the biggest concerns we have is that the modern internet is basically run and owned by a handful of players. 4 or 5 are owning most of the internet. And that means any digital data, anything that gets written, anything that gets stored, and any services you're provided are all run on infrastructure owned by these 5 players. That's not good, because it means that at any point there are censorship problems, they can go offline, you're not in control of your lives. And for us, we find a solution in through ICN. And let's take you through it. There are many layers to this system. We'll take you through it one by one. But we'll start at the blockchain level. Blockchain, I think, is what underpins a lot of Web3 technology. For us, this is one core part of what makes this work. As many of you community members already have, you own links, ICN links, and these are the NFTs that are used to activate our hypernode network. And we'll talk more about the hypernode network in a second. But importantly, the blockchain is a decentralized ledger where everyone can transparently record the status of the system. This is important just to make sure everything's verifiable, but it means that we use the blockchain to secure a lot of the parts of the system that require verification. And so we have things like the ICN link, which are used to activate our hypernodes and to verify work. We have the ICNT, which is a core security collateral mechanism to make sure that our hardware resources below are secure. And we have something called satellite proofs. So on broad strokes, what we have is a cloud system operated through a network of hardware resources that is decentralized, provided in a decentralized way. And they're added here as a hardware resource. These hardware providers, people that provide these hardware resources, will collateralize them to secure them in a decentralized manner with slashing risk using ICNT. And it's the role of ICN link holders and the hypernodes that they run to verify and submit proofs that these resources are operating well. In this decentralized ecosystem where we're able to verify the performance of our hardware, these hardware resources can then be used in any service or application. So instead of running it on, let's say, AWS, we could run it on ICN, where you can be sure that the hardware is sourced decentralized in a decentralized way, and the performance of it is also monitored and secured trustlessly. And how do we do that? So we talked about the hypernode network.
Quick question, Chris, before you go further. just to, or maybe a clarification here, you see here the hardware resources, and of course we've spoken about what the services are that are living in Impossible Cloud Network. This can be cloud services like cloud computation, cloud storage, which is also the first product that has been launched successfully. So if we say the hardware resources that are somewhere connected to the blockchain, the data is not stored on the blockchain, is it?
No, no data is stored on the blockchain. So all we are verifying on blockchain is the security of the hardware.
Got it, because I think that sometimes people get mixed up. They ask, okay, you're a decentralized cloud storage company, so that means you store data on the blockchain for some reason, but that's not what's happening.
It's exactly. It's a key point. I think when we think about the role of blockchain in a lot of ecosystems, I think it's prudent to make sure that blockchain does support a vital role, but also the appropriate role. And we don't put much on the blockchain, but what we do put are the key pivotal core parts of what drives security of the system. And when we think about hardware resources, these hardware resources are more about verification of them and registration of them. So we know where the hardware is, we know where they come from, and we can verify that they are working properly. Any data, and you rightly raise any data, any usage data, anything pertaining to what happens at the hardware node is not put on chain at all. It's completely separate.
Understand. So the hardware nodes interact with the blockchain, but there's no data being stored on the blockchain, as in no customer data, of course. And also there's the ICNT living on the blockchain, the ICN link NFT living on the blockchain, and then there's what you're now going to talk about, the satellite proofs happening there as well.
Exactly. So let's move to satellite proofs, because satellite proofs are what prove the performance of our hardware network. And what is a satellite network? The satellite network can be considered a data availability network for hardware proofs. So this is a publicly available, always available network of data that people can query and understand what is the status of our hardware network. So obviously we're going to have a very deep hardware network consisting of a lot of hardware classes, a heterogeneous set of hardware capabilities. So we want to range from storage classes all the way up to compute and other kinds of hardware. And it's up to the satellite network to report and make available the reports on the hardware network. The satellite network themselves, they don't do the verifications, but it's pivotal that the satellite network remains a constantly orbiting system around the main network that does the work, which is the hypernode network. Now, the hypernode network is a set of nodes that secures the system. And this is where your ICN links come in. Everyone that's bought a node has bought an ICN link, and ICN's link, when linked to a hypernode, activates it and enables it to do verification work. When verification work is done, rewards are earned, and those rewards are basically rewarding you for securing your network. So this hypernode network is an interconnected set of security nodes that monitor and verify the hardware network below. And it does this by checking every single hardware network, or scalar node, that we call them in our hardware network, and submits these reports and checks to the satellite network, which then publishes it to the blockchain. So we have a very deep integrated stack here. The blockchain here is to make sure that everything is verifiable. The satellite network is to make sure that data is always available about the network. A hypernode network is where the core security exists. And the role of this network is to constantly monitor and secure our hardware network. And here, the role of the community is key. This is a decentralized network. We want the community, as many people as possible, to contribute to this. The more contributions, the more secure it is. And I think that's where the core values of Web3 come in. I think the security of a network is only as strong as the strength of a community. And as it should be. With a decentralized network, you need to crowdsource the capabilities from the crowd. And the security comes from that. So all you ICN link holders staking to this network, you're the source of the security, and we need you to help secure our system. So this we can see as really the nexus of trust or trustlessness of the system. Without the hypernode network, the hardware network would not function. It wouldn't function without proofs, and I think the ability for misbehavior, which happens at the hardware, can happen at the hardware network layer, is solved through the hypernode network. So let's talk more about our hardware network. We see our hardware network as, let's say, a foundational layer of resources. We want to see it as just a pool of global compute resources that can be accessed by anyone everywhere. Each node can be committed, and each one, we call them scalar nodes, because they help scale the capabilities of our system. Each scalar node can be any type of node. So it can be a storage class node, it can be GPU class, it can be compute class, and everything in between. The idea for us is that we want to build a fully capable, a fully realized set of resources that doesn't restrict and is unopinionated on the scope in which we can provide these resources. What we want to do is allow the community, allow the decentralized network to decide a demand and supply function around what resources can be provided to who and by who. So again, it's a decentralized network and anyone can add them. And I think the key part is this is capable, again, through the security provided by the hypernode network. And as our hardware network scales through the addition of scalar nodes, so does the capabilities. And those capabilities allow us to develop what we consider as the next generation of the internet, built on a trustless foundation. And we can enable many things. I think when we think about Web3 projects, even layer 1 blockchains noted here, a lot of that infrastructure still runs on Web2 archaic cloud. And we, I think, as a Web3 movement, deserve a better class of system. So not only do we support that, but a lot of other solutions, or let's say projects that aren't enabled by Web2 cloud can be done through ICN. And here's just an example of everything that we can enable. This is a small set of, I think, what we see and endeavor to build as the future. All of these are open. So our application and service layer is a composable baseline. The idea is that we provide building blocks in the form of resource-aware APIs and SDKs to allow people to build any kind of service or application that matches the resources that they need. So obviously AI use cases require a lot more GPU or otherwise compute for the models, and they can access specifically the kind of resources required at the hardware layer. Similarly, if we want to do something related to do centralized data store, you know, you're fed up of having data stored centrally in one place. There are hardware nodes that are storage enabled that allow people to build services of this type. Here, the idea is that we want to break out of the mold in terms of typical cloud services. AWS gives you a suite of services, and that's kind of all they offer you. It's not as efficient because it's not resource aware. We want to provide a composable and decentralized way, not only for people to use these services, but to build your own.
Can you maybe for one moment zoom out a little bit? So we have the application layer plus the hardware layer seen together in one picture.
Sure.
So I think what's crucial to understand here is that all this part that you are showing here, the hardware network plus the application and service layer, in traditional infrastructure, this is all run by one company. So
Exactly.
what the core of the project ICN is doing, and what's of course the slogan decentralize the internet, what this means is that the project we are building enables the decentralization of
exactly
these aspects, the application, the services, and the infrastructure that this runs on. Maybe you can go into a little bit more details
Yeah,
on that?
well said. I mean, let's take our friendly example, AWS, the hyperscaler. You think about, how do they provide cloud services? They own the whole stack, from the data center infrastructure all the way up to the service software stack. And it means that, what happens when the hardware shuts down? What happens when the services shut down? What happens is AWS goes offline? They own the whole stack. And it means that without this level of flexibility, there's a few problems. One is on the innovation side, and that's what we're kind of solving at the application and service layer. Given the fact that the services they offer is bound to what they provide as a suite, it's boxed into what you're acceptable of regarding what they can provide. With us, we say we don't provide restrictions or limitations on what you can build. And I think that's the key thing. It's you can build it too. So at the service layer, we want to enable a kind of value creation that doesn't typically exist in modern cloud. Why? Because services are, take it or leave it, right? It's AWS offers you a certain service and you either use it or not. Right now, there isn't a role where service providers can decide in a composable way how to build a service that isn't already, let's say, compatible with current Web2 cloud. Why? Because they don't have a deep connection with the hardware network. And that's what we're enabling here. And so with this hardware network, we want to open up a permissionless set of hardware resources and present that to a service layer where anyone can leverage the exact kind of resources they need and design a service that may be specific to their customers or their use cases, which currently isn't possible. And for us, we think that it enables a lot more innovation, as well as decentralizing the risk around the operational side.
Maybe adding to that exactly what you've just said, currently this application layer is controlled, as mentioned previously, by these centralized companies. And what currently does not exist and what we are trying to enable with ICN is competition on the network, so to say. And we've seen this throughout history in many, many infrastructure-heavy markets where large corporations or the state has been owning the infrastructure, like rails or like large ships, etc., or like the telecommunication market, also an example for this. And then there was suddenly introduced, either by law or by innovation, competition on the market, which led, or like, not on the market, on the rails, so to say, on the infrastructure. And this is precisely what we are enabling here in the decentralization of the application and the service layer, because we believe it is far more innovative and there's far more services that have never seen the light of day because they can't build out a hardware network by themselves that they have unlimited access to, etc., etc. And that's also, I think, a huge value proposition here, enabling competition on the network and on the hardware network, and therefore, of course, enabling much more innovation, etc.
Yeah, I mean, let's talk about Rails, because I think it's a great point, and there's some analogies that you see in the real world. When you think about, let's say, the British Railway, back in the day, you had very specific rail gauge widths, which only enabled certain trains to be able to run on. And that's what we're seeing here. There are certain rails in which the infrastructure is built on that restricts what's capable. And for us, we're opening that up on both sides, at the hardware layer and at the software layer. And we want to provide an open ecosystem where the hardware network can decide what kind of rails it wants to run on. And based on those diversified set of capabilities, allow a more dynamic service layer to build any kind of use case on top. And it's key that neither side is restrictive. And ICN protocol, being open and permissionless, is designed so that the network as a whole decides in which way it wants to grow. And I think that's how the internet should be. It's an organic organism. It could grow, change shape, change size, depending on the needs of the network.
And also this makes it so much more flexible, so much more scalable, because suddenly it can not only grow two-dimensional, but as in like if we've seen with multiple decentralized networks,
Right.
Bitcoin, or also you could say Airbnb, and how like hosts have been growing on the Airbnb network, scaling much faster than traditional centralized hotel companies. They can grow in 3 dimensions, right? Or like multi-dimensions, right? Because there's many individuals, many atoms, so to say, with their own incentives that are all contributing to the growth of the network, and that's not possible in a centralized network.
Yeah, exactly. I mean, when you look at centralized solutions, let's look at AWS. When you think about scalability, Web2 is hitting the limit of its ability to scale, and it takes hundreds of billions to now scale it even further. AWS, in order to scale their operations, have to commit a lot of investment, and that stifles not only growth but also innovation. There's a lot of demand that can't be met because Web2 is failing to scale to the needs of the network. And the whole purpose here is that with an open network, with the ability to have boundless growth, we can outgrow Web2 cloud and reach a system where it better serves the needs of the wider internet. And we want to see this, right? We want to see an application layer that grows with the hardware network, and the hardware network grow with the service layer. As much as the needs of a network grows, the capabilities should meet it, and only then will we be able to like build the internet of the future and in a more robust and secure way. And I think that's not possible today.
Super, Chris. This is very, very informational, very insightful. I think also for the community. Would you be open to, for the viewers, once now we've gone from the blockchain stack all the way until the visionary, the internet, etc. Can we maybe start at the bottom and then, once to close this off, go all the way through back up to the blockchain? Is that possible?
Yeah, good idea. We can do that. Yeah. I mean, let's look at the internet. It's what drives our daily lives. It has everything. It has all our personal information. It has our music, our favorite videos, cat videos, but also our money. Everything runs on this. And what does the internet run on? 5 main players, 5 core infrastructure providers. Is your data safe? They claim it is. Safety, I think, like beauty, is in the eyes of the beholder. I think the user needs to decide by themselves, is this safe? Can I get my data whenever I need it? And can I make sure that the things I rely on will always be there? Those can't be answered today in Web2. In Web3, we're trying to solve that. And how do we change this? So it starts right from rebuilding how those core functionalities that you use the internet for, how those are built. And obviously, if we work backwards, it's the application and service layer. So these main use cases that you rely on that drive value in your life, they're served here, and they're built on a hardware network that is decentralized. The key thing about the application service layer here is, in a decentralized way, we predict, or we hope that a whole host of new solutions that can better meet the needs of the consumer can be built, because we're offering a more efficient, resource-aware system for people to build, let's say, specific use cases that are well engineered to function on specific hardware. And that's only made capable by a resource-aware application and service layer. We invite people with a composable layer to build these as required in order to meet those needs that the network clearly has. And how does that happen? Through our hardware network. And this is an open network of resources that anyone can access. So the key part here is, we want to build a system of global compute that can serve that wider internet, where you can decide as a user how you want to store your data, how you want to define your trust levels, and our hardware network, being resource aware, provides that. So With this level of decentralization, gives a level of optionality for users to decide what kind of applications do they want to use, to what trust level, and where do they want their data to be stored. And the dynamic composability, flexibility aspect of the hardware network supplies that. Obviously, with it being a resource network, it's paramount that these resources remain secure and robust. Traditionally, in Web2 cloud, you take the promise that the cloud provider will always keep the service running. In Web3, that's not enough. We need proofs, we need verifications, and we need clear incentive to make sure that these resources will always be available. And that's guaranteed by our hypernode network. So this is, again, the central network of hypernodes that collaborate together to monitor our resource network of hardware nodes. And this is community-driven. You stake your ICN link here to activate hypernodes. When activated, they'll be able to do work. And for the verification work done, everyone will earn rewards. So I think the key part of security here is making sure that there is enough security. The hypernode network requires a lot of contribution. The more stake and value locked in the system, the more secure or the more confident we can be in its security. And ultimately, its job is monitoring and providing those checks to an orbiting satellite network, where we can transparently provide reports publicly to on demand regarding any part of our hardware network. So each scalar node in our network is checked, and we'll have a report published that defines, okay, is it doing its work properly? Is it online? And if it's not, it will be subject to slashing. All of that can then be submitted and checked on-chain. So all of these slashing mechanisms, all of the rewards, all of the proving, and all of the registration and securing of the hardware resources happens on-chain. So the blockchain is what then ensures and secures that there is a deterministic execution of these functionalities, and is where also any ICN link holders and any asset holders will be able to manage their positions, stake, monitor the network, etc. That's it, bottom to top.
Super. Yeah, I like the bottom to top approach, actually, because you can start with the internet, something super tangible, super understandable for everyone in the community, everyone watching, and then you can just distill it down. Okay, the internet, cloud services, and then everything that follows, all the way until this final settlement layer, where all the economics and all the automated things are happening, which is in this case the blockchain. Super, Chris. I like it a lot. Anything to add from your side? Anything we left out? Anything we did good? Anything we did bad so far?
I mean, I think the community's been waiting for some kind of news on the project, and I think we're super excited to be able to share this. This is, for us, a deep innovation that changes the way we think about internet infrastructure. We need to decouple all of the roles that are very, let's say, integrated and coupled together. It's very fragile. It stifles innovation, but importantly, I think it doesn't support a trustless environment. If we're to move to a future, we need to support the core tenets of Web3, which is trustlessness, verifiability, and for us, digital sovereignty, and returning that to the user. We think ICN protocol is the future for that.
Hi everyone, it's Jan again. Thanks a ton for listening to our conversation with Chris today. If you're curious about ICN and want to stay updated, be sure to follow us on our socials. You'll find all the latest news, updates, and more about ICN there. We appreciate your support and look forward to bringing you more great content. Until next time.